do a chain rule sort of thing?
Yeah.
Okay. So so we could say that u is x squared minus 1, and v is e to the u.
Mm-hmm.
Um, so u is x squared minus 1, v is e to the u. So u dash is 2x, and v dash is e to the u.
Okay.
And here it would be chain rule.
Yep.
Yeah. So then it's v. I forgot how it goes. Is it just 2x times e to the u?
Yes. Yep.
So then it becomes 2x, times e to the x squared minus 1.
Yes. And so I just usually do it as differentiate the whole thing. So with e to the x, it stays the same. And then it's times by the derivative of the function inside the function.
Yeah.
So yeah, whichever way.
Just sort of reminding because I haven't touched this for a little while.
Yeah, that's all right.
But yeah.
But whichever way, like if you prefer to kind of fully do it like that. Yep, this stuff. Okay, let's try this one down the bottom.
Okay. So again, chain rule sort of idea.
Yep.
So u equals x cubed minus 4x, and v is equal to ln u. So u dash is 3x squared minus 4, and v dash is 1 over u.
Okay.
So then it's just 3x squared minus 4 times 1 over x cubed minus 4x.
Yep.
So yeah, it can just be written as a big fraction. So 3x squared minus 4 over x cubed minus 4x.
4x. Yes. And you can't factorize anything from the top, and so I don't think it gets any simpler. Yeah, won't get any simpler. Okay, how about this one?
This is quotient rule.
Yeah.
Yeah. So that's v u dash minus u v dash u over v squared. So it's always v over u, isn't it?
U over v.
U over v. So then u equals ln x and v equals 2 to the x. So then u dash equals 1 over x, and v equals x 2x, right?
2 to the x, is it?
Wouldn't you bring down x to multiply it and then remove it from the power?
Do you know what the derivative of 2 to the x is?
I just thought it was 2x, but I'm not sure.
It's 2 to the power of x times ln 2.
Oh, okay.
So if y is equal to any number to the power of x, then dy by dx is equal to any number to the power of x times ln of that number.
Okay.
So using that rule for a second, if y was equal to e to the x, what would dy by dx be equal to?
It's just e to the x still.
So it would be e to the x ln e?
Yeah, which is 1.
Which is 1, yeah. And so e is just a very special case for that.
Yeah. I remember that that thing now. Okay. So then you do 2 to the x times 1 over x minus 2 to the x ln 2 times ln x all over 2x squared.
Yep. 2 to the x squared. And I wouldn't simplify that.
Okay.
Oops. Because if they then said like find the gradient or something, you would then just use that. Did they simplify it? They did. So 2 to the x times 1 over x ln x. Da, da, da. Yeah. So they then simplified it. They didn't say give it in its simplest form. There's, we'd cross that bridge if and when we came to it. And I don't think you ever are asked. You'll be asked something like find the gradient when x is 3. You would just sub in 3 for x. It doesn't matter what form it's in. Let me see. These are okay. Let's do question 2 part 2.
Two part y equals 7 to the 5x. So would that still be a chain rule sort of thing?
Yeah.
Okay. So the derivative of 7 is nothing. Actually, hold on. U is equal to 5x. V is equal to 7 to U. U dash is equal to 5. V dash is equal to 7 to the U ln U.
Yep.
So it would be 7 to the 5x ln 5x times 5.
Yeah. So 5 times 7 to the 5x ln 7. Yep, that's it. Let's see. Those ones were okay. They didn't give it any trouble. That was the only one that I thought was any. Find the value of the gradient. How would you do 5 part 1?
5 part 1. Each find the value of the gradient of a curve at the given point. So you would differentiate that one first.
And then what would you do?
And then you'd have the differential function. So you just plug in 1 for x. You find the gradient.
So I think you can just do that straight with your calculator.
Sure. Also, I found out that for the entrance exam that I'm doing next month, they only allow the very basic Casio calculator.
Okay. And do you have that calculator?
I do.
Okay, let's practice with it.
Yeah.
Or I can.
Oh, the one that's even simpler than that, because it says that it cannot have any differential or integration functions on the calculator.
Okay. In that case, you'll be fine for this question. I was just checking that for this type of question, the most efficient way to do it would be just putting it in. I was just reminding you of that. But let's do this one. First minimum P. Yeah, I just want to. And so, how do you find the minimum point?
Sorry?
How do you find the minimum point on a graph?
I'm thinking of completing the square.
There's a much better way.
Not sure. When the gradient is 0.
Yes. And
Yeah.
how do you find the gradient of a tricky curve?
Differentiation.
Yes. So the minimum point is when dy dx is equal to 0.
Yeah.
Um,
Would this one be product rule?
and then that one will be product rule. Like, I'm pretty confident that you're going to be fine with that. It's not tricky. Nothing tricky about it. So this one might be worth something. Let me see. 8. If they ask us to differentiate that. Yes. And then find the coordinates of any turning points. This one might be worth doing. Okay, let's find the derivative of f of x, question 8.
Okay. So this one is product rule. So would you be x squared or ln x squared?
You tell me.
Probably x squared because it's in the bracket.
For which rule?
Well, either, just u equals.
Is it chain rule, product rule?
Oh, this one's product rule.
So for the, it's not ln times x squared, it's the ln of x squared.
Right. So u is ln x squared.
Yeah, u is usually the first one. Doesn't matter, I suppose. But
okay, so u is x in this case, and v is ln x squared.
yeah, won't matter. But
so u dash is 1.
Yeah.
And v dash is chain rule.
Yes.
Which is 1 over ln x squared. No, 1 over x squared times 2x.
Yeah.
So then you do u dash v plus v dash u, which becomes x plus. Oh wait, no. Which becomes ln x squared plus x times 2x over x squared.
Yeah. What would that simplify to?
Ln x squared plus 2x squared over x squared. So it's just ln x squared plus 2.
Yeah. And let's see. That's it. Yeah, that's it. So that's that. That's fine. How would you find any stationary points?
Stationary points are when the rate of change of gradient is 0. So the second derivative is 0.
Nope. You said it earlier. It's when
stationary points. Oh, gradient is 0.
Yeah.
Okay. So here we just equate it to 0 to find x.
Yeah.
So ln x squared equals -2.
Yeah.
I'm not sure how to solve these.
To eliminate ln, you raise both sides to base e.
Okay.
So it's basically e to the ln x squared equals e to the -2.
So then e would the learn stay? Would it stick? Would it go?
The left side would become x squared.
Okay. What happens if you have ln? You can't have ln to the e, can you?
It has to be the ln of something. Like
Yeah.
sine, cos,
Yeah.
or tan. It has to be of something.
And then you just x equals the root of e to the -2.
Yes. And plus or minus.
Plus minus.
Yeah. So you're going to get two different ones.
Yeah.
Minus e to the -2. What if they ask for the coordinates of the stationary points?
The coordinates of the stationary points. So we found the x value of a stationary point, right? So then we just substitute it back into the original equation at the top.
Yeah.
And that would be the plus minus of them. So using the calculator, because it would be plus minus root e e to the -2. So that's plus minus 0.367. And then from that you just put in the equation at the top to find what y is.
Yeah, and you could do it exactly. So e to the -2, and you could put in like e to the -2 times that. So
Can you square root e?
Yeah, you could.
Okay. Oh, I think you just may have forgotten to write it down. That's it.
Oh, the square root. Sorry. Square root, and in fact, because it's to the -2, I think you could. Yeah, you could do 1 over e. So that's just 1 over e.
Okay. So it should give the same result.
And then you could sub that into the other one. So 1 over e ln 1 over e squared. And then just the negative of that as well.
Where does 1 over e ln 1 over e squared come from? Oh, is that just the formula?
I just subbed it in.
Okay.
Instead of x, yeah.
By the way, what are parametric equations? Because that's something else that's related to this topic.
We could look at parametrics. In terms of differentiation, they're easy peasy. Let's see. Oops.
Or could we do kind of trig differentiation of trig functions and then move on to the parametric?
Yep. Parametrics are very easy to do. Okay, differentiate this one down the
bottom. Okay, so y equals sine 3x. Is the derivative of sine just cos?
Mm-hmm.
Or is it? Okay. And the derivative of cos is minus sine, right?
Mm-hmm.
Okay.
What's the derivative of minus sine?
Minus cos?
Yeah. What's the derivative of minus cos?
just sine?
Yeah, and it goes back around.
Okay. So that's just cos 3x. Do you need to bring the multiplying factor to the front or something?
Yeah, the function inside the function.
Oh, so you'd think of it as chain rule almost.
Yeah.
Uh-huh.
It is chain
Okay.
rule.
So it's 3x times sine 3x, yeah. Cos 3x.
So what's the derivative of the function inside the
Three.
function? Yeah. And so it's that times 3.
Yeah.
So that's just where that comes from. It's just sine rule. Oh, sorry, just chain rule. 3 cos 3x. Right. It's a bit easy to do
So this is product rule. So we think that u is equal to x squared, v is equal to cos x, u dash is 2x, v dash is cos x. So then x squared times cos x plus cos x times 2x.
Yeah. What was the first half, sorry?
X squared times cos x.
What's the derivative of cos x?
Oh, minus sin x.
Yeah.
Yeah, and it's not over v squared. No.
Minus x squared.
Um,
Sin x.
yep.
That's it.
So it's minus sin x cubed.
No,
Plus-
no.
No?
That's yeah, you're done. It's not times x, it's times sine of x.
Uh-huh.
So it's
Okay.
a very, very different, like, it's a very different and much smaller number. Yeah, so
Yep.
it's not the same. Okay, how about this one?
Y equals tan x cubed minus 1. So this is chain rule. Yeah? Yeah.
Yep.
So u equals tan v equals x cubed minus 1. U dash is it something like 1 minus tan over tan squared? Or am I thinking of double angle formulae?
You might be thinking of double angle formulae. There's a formula for the derivative of tan that's given to you. Do you have the formula thing there?
I don't have it on me, no.
I'm sure they'll give it to me in a second. They're saying chain rule is that. So it is sec squared u. So tan x, the derivative is sec squared x.
So we can write it sec squared v in this case.
Yeah, if you want to.
Sure. And then v dash is then just 3x squared. So then since it's chain rule, it's sec squared x cubed minus 1 times 3x squared.
Okay. And is that simplest?
Well, 3x squared sec squared x cubed minus 1.
X cubed minus 1, that sounds good. 3x squared sec squared x cubed minus 1. Okay, trig. So tan, they give you that sec squared one. Sine cos, Thank you. Okay, let's do question 3, part 2.
Okay. Y equals e to the tan x. Y equals e to the tan x. Okay, so chain rule where x is e to the u, where u is e to the v, and v was tan x. So u dash is e to the v dash equals sec squared x, and then it's just sec squared x times e to the tan x.
Yeah. So that tan x. Okay, fine. So just practicing the tan thing. Quotient rule, chat rule. Those are fine. That's weird. Verify these results. How would you do 7 part 1? Oh, this might. I'll verify the following. No. They'll give you those. They give you those formulae, so that's just kind of a. It's just kind of a nice question to kind of see where it comes from. Sine x plus 2 cos x of the 3 turning points. Okay, how would you find the turning points for this one?
The turning points are when the gradient of the line is 0. So you find the gradient by differentiating that. So y equals sine x plus cos 2x. With something like this, would you differentiate them independently?
Yep.
So y equals cos x plus minus 2 sine 2x.
Minus 2 sine 2x. Yep.
So that's just differential. So then 0 equals that equation. And then you want to solve it for x. You want to find out what x is. Would you have to do some identities to figure out?
At the. Sorry, that's dy by dx. So
Yeah.
at the turning point, that's equal to 0. Should be able to solve it as it is. Oh, no. You will need to. Go on. What identity do you have to use?
With its 2 sine 2x, I'm thinking double angle formulae. I'm not 100% sure.
Yep.
I'm not sure. I can't remember the sine double angle formulae.
Sine 2a is equal to 2 sine a cos a.
2 sine a cos a. Okay. So then it's cos x minus 2 times 2 sine a cos a. And then would you expand the bracket?
Yep.
So 0 equals cos x minus 4 sine a cos a.
X.
X. Oh yeah, x. There's still the sine in there, so would you divide everything by... Oh, I don't know, because then we'd get tan. Would you divide by cos?
Yeah, that'll work.
So 0 equals, if you divide by cos, 1 minus sine of, so that's sine over cos is tan, right?
Yeah.
So 4 tan x, 1 minus 4 tan x.
Yeah.
And then, yeah, you could figure it out. So 4 tan x equals 1 tan x equals a quarter.
Mm-hmm.
So that would find you 1 point.
Okay.
I'm not sure what that would give you the x points of the. So then you take x that you find and put it back in the original equation to find the y coordinate.
Yeah.
But I'm not sure about that turning point at the bottom, how you'd get to that.
So did you get inverse tan of a quarter?
So x, yeah, equals arc tan a quarter, which is 14.03.
Okay.
04.
I'll just say 14.0.
Sure. And then you substitute that back into sine 14 plus cos times 2 times 14.
Yeah.
Which gives you one value. Which seems a bit unreasonable.
No, go on. What was it?
So 14.23.
14.2. How do you get a second answer for tan?
Do we still look at it in terms of tan?
Yep.
Why is that?
We converted it to tan.
Okay. So then for tan you just add pi over 2
Yeah.
plus minus pi over 2.
I assume you're in degrees, so it'll
Is
be
max
180.
180? 180. Yeah.
180 is pi over 2 because 14 degrees.
Uh-huh. So yeah, then it's just 194.
So it looks like this first one was 14. This second one's 194. Now you gave in degrees. They are obviously have it in terms of.
Oh, they have it.
radians.
Yeah, that's what confused me a bit.
Okay.
And then you can also have x equals 14 minus 180, which becomes minus 160, 66.
Yeah.
So we found 14,194. What about the one between them?
That's not as. Let me see. What did they say? They said the 3 or something. I thought they said we could just keep finding more. Did they want of the 3 points in the range between 0 and pi? So they wanted these 3 actually.
Yeah.
Oh, so maybe this one here is the 1941.
Could it be? Yeah. 2 pi is 360 degrees, right?
Yeah. Yeah, so
Uh,
this one is 14 degrees. That's very close to 0. Then this
Yeah.
one is like a bit kind of halfway-ish, 180. Yeah. So then this is like 374 degrees, or in radians, whatever that is.
What is 2 pi equal to in radians?
Say it again, sorry?
So here the x-axis is measured in radians, right?
Yeah.
So where would 360 degrees be on that line?
It's 2 pi. It's like pi is 3.14, so 2 pi is... Oh, I see what you're saying. So let's see. So well, we can just see, who knows if their graph is to scale. If we do arctan 1/4, so that gives us, I'm in degrees. If we do setup angle unit radians, so that's radians, 0.245. So that's 0.245 is that first one. That answer plus pi is 3.39. And then the third one would be just plus pi again. 6.53.
That doesn't line up to their scale.
Yeah, actually, hang on. Oh, hang on. No, wait. No, should be fine. Let me just check. They wanted between, for the coordinates, to x is between 0 and pi. So pi is 3.14. So they're talking about those three things. Is it because we have between 0, x, and pi, but we had 2x, and so that's going to be 2x and 2 pi? And so we would half all of our numbers? But I don't... Let me just see. So we converted it. So that sine 2x was 2 sine x cos x. We can do it a different way. Let me just think about this. That's 1 minus 4 tan x. 4 tan x is a quarter. Yeah, looks good. The other way we can do this is by factorizing. Cos x. Maybe I'll just copy everything. So if we were to factorize the cos x out, what would you get there?
We would factor out the cos. Oh, so factorize it, not divide by it.
Well, what we'll get is like 2 sets of solutions. So it's just a different way of going about it.
So we'd get cos x brackets 1 minus 4 sin x.
Yeah.
So cos x equals 0, or 1 minus 4 sin x equals 0.
Yeah. So that'll be the same thing. X equals arc sine a quarter.
How would you solve 1 minus 4 sine x equals 0 so quickly?
Equals 0.
Yeah.
Just 4 sine x equals 1. Sine x equals a quarter.
Aha.
X is
Okay.
x sine a quarter. Just say it like same as time. And so did you get answers for that?
Sorry?
Did you get answers for that one? X sine a quarter.
Yeah, it's just takes a bit of time to load. I still have it in degrees. So I get 0.25, 2.8, 6.5.
Yeah. So roughly 0.253.
Yeah.
And the other possibility was cos x equals 0.
Yeah. I just written that. And deleted. Is it just like pi over 2 and then 3 pi over 2?
Yeah. And so shift. So how would you get an additional answer for sine?
For sine, you do 180 minus.
Yeah. And what is 180 in?
That's just pi.
Yeah.
So pi minus 0.253. Wait.
0.253.
Yeah. Is that in terms of, yeah.
So that's 2.89.
Yeah. 2.89.
Yes. And so those, let me see. So between 0 and pi. So this is bigger than pi. So that's outside the range. So I think it's just these three.
0.253, 0.289, and pi over 2.
I believe so. So let's see. So pi over 2, 2.889. Did it only give... And they just subbed them in to get the y. Hang on. Hopefully this will get bigger. That's question 2.
I think we found the point, so we just substitute them into y, and then that's that.
Yeah, and then that's that.
Yeah.
Okay. And, okay. If you want, we can quickly look at parametric.
Yeah.
So parametric differentiation. So parametric is where they separate out the y's and the x's.
Sure.
And so it's parametric differentiation. It's literally the derivative of the y over the derivative of the x. So what would be dy by dx for this one?
Um, there are two equations. Would you do both of them? Differentiate both of them?
Yeah. But it's literally like the derivative of the y over the derivative of the x. So what is the derivative of the y?
Derivative of y is just 2.
Yeah, so it's going to be 2 over, what's the derivative of the x?
2t.
Yeah, so 2 over 2t, which simplifies to 1 over t.
What do parametric equations show or do?
You can take, like, there's an equation that's kind of complicated. Basically the y, the x is kind of going up in t squared each time. The y is going up in 2t each time. And so if you put the two of them together, they might make a kind of complicated equation. But if you separate the two of them, they're much simpler. And so,
Sure.
yeah, you can just differentiate them very easily like that.
Okay.
So find the equation of the tangent to the curve. Okay, how could you do that?
Have a good at the German point down.
No, let's skip to part 3.
Okay. Find the equation of a tangent where the point is t equals 3. So you would find the gradient at the point where t equals 3. So you just do 1/3. M equals the third. And then t where t equals 3. So we've got a third, and we want to find out what the x and y points are now to get an equation for line. X equals 3 squared, and y equals 2 times 3, which equals 9 and 6. So then y1 minus y equals x. So 6 minus y
No. Y minus 6.
No. Y minus 6 equals a third x minus 9.
Yeah, and you don't need to, they didn't say do anything with it.
Okay.
And how about part 4?
Part 4, eliminate the parameter to find the Cartesian equation of the curve. Okay, so they want to get rid of t, right? The only thing I can think about is integrating.
Make t the subject. Can you hear me? I can't hear you. Not sure if you can hear me. I'm gonna try closing calculators or something.
And y over 2 equals t as well. Would you just substitute in like root x equals half y? 2 root x equals y.
X equals
just have to sketch out somehow.
X equals
Oh, so y equals root. Oh, okay, just like the x.
turns out the point where t equals 3 tangent.
So sketch a curve. I'm not sure would it be like an exponential sort of thing.
T equals 3. Yeah. The x-axis has its line of symmetry. So
Why would it be rotated?
it's kind of tricky. Let me parameter t equals 3.
So then you would see it's free, so would you use the x and the y value for that? That you had sorted before. So yeah, 9 and 6.
Yes. 0, 3. Yeah. That's that anyway. Yeah. How was that for you, Gregoire?
I'm not sure. I'm not here next week, Monday.
Okay.
So it won't be, yeah, it won't be next week. It'll be the week after.
Okay. Sorry.
I'll let you know then what I'd like to do. It'll probably be based on the syllabus I sent you last week.
Okay. Anything else?
No, that's it.